Hello everybody, hope you're doing well. This is going to be an example. It's going to help you guys with concept 2 on the vector project. So let's talk about a speedboat. All right, it's going to be returning to port on a heading of south 28 degrees west. The boat is traveling at a speed of 137 miles per hour. The current is flowing at 8 miles per hour, and that's on a heading of south 10 degrees east. Okay, so the first thing we're going to want to do is construct a vector diagram that represents a situation. Part A says what is the actual speed of the boat to nearest hundredth, so obviously that's going to be the magnitude of our resultant vector. So we've got a boat headed at south 28 degrees west. So if we draw that in, this will be our boat vector. South 28 degrees west, which means that angle right there is 28 degrees. Okay, so next we've got the current. The current is flowing at 8 miles per hour on a heading of south 10 degrees east. So south 10 degrees east. We want to kind of draw these to scale. So 8 miles per hour is a lot smaller than 137 miles per hour. So this vector would be shorter, and then this angle right here is going to be 10 degrees. Okay, so what we're going to do next is we're going to construct our resultant. So easiest way to do that is make this parallelogram, and then I know this right here is going to be the resultant vector. Okay, so now what we need to do is we need to get component form of these two vectors. So I know this magnitude here is 137, and I know this magnitude here is 8. So if I want to get component form of my boat vector, I'm going to have to take the magnitude, 137, times cosine of the angle, and then 137 times sine of the angle. Now notice I didn't put the angle in yet. This is probably one of the most challenging aspects of doing these vector diagrams when it comes to headings. So what I need to do for a vector angle is I need to get what I call the math angle, which is this right here. Think of the unit circle. So to get that angle, what I need to do is I actually need to take 270 minus 28, and that gives me this angle right here. So 270 minus 28, that's going to give me 242. So this right here would be 242. Okay, so then obviously what we're going to do is we're going to throw those into the calculator. I'm going to round to the nearest thousandth. I got negative 64.318. And for this one, I got negative 120.964. Okay, which makes sense because if you look at your boat vector, that's in the third quadrant. So when you look at these two, they should both be negative because that would be the coordinate of a point in the third quadrant. Okay, next, let's get our, let's call that one C, our current vector. So again, the current has a magnitude of 8. So I know it's going to be 8 cosine something, 8 sine something. Well, again, the tricky part here is getting the angle. I need the angle that represents that. So in this case, you can see what I'm going to do is I'm going to take 270 plus 10 degrees to get that angle. So this is going to be 280 here and 280 degrees here. And again, I'll just throw that into the calculator, round to nearest thousandth. So I got 1.389 and negative 7.878, which again should make sense because if you notice the current vector, that's in the fourth quadrant. So you want an x value that's positive and a y value that's negative. So yeah, that one works out. So now what we want to do is get the resultant. Well, the resultant vector is simply going to be the boat vector plus the current vector. Okay, so what I'm going to do is I'm going to take these two right here and add them together. Okay, and in doing that, I got negative 62.929 and negative 128.842, which again makes sense. And this is why it's important to draw your vector diagrams to scale, because I can see that this vector is in the third quadrant. So both the x and y should be negative. So now, last thing we're going to do is we're going to find the magnitude because I want the speed. Okay, so the magnitude of that is going to be the square root of the x squared plus the y squared. Again, the negative here doesn't really matter because you're just going to be squaring it, so it's going to become positive. All right, and if I throw that into the calculator and round to the nearest hundredth, I got 143.39 miles per hour. Okay, so that would be the actual speed of the boat, taking into consideration the current. Okay, so the next part. This is the same diagram we just had on the other page. What is the actual heading of the boat to the nearest minute? So now what I want is, what is this heading right here? Because that's the direction the boat's actually going to go. If you point the direction here and the current is pushing on it this way, the boat will actually travel along that vector. So I basically need the heading of that. So really what I want to do here is I want to use my inverse tangent equation. I want to find the angle of that vector r. So that's going to be inverse tangent of y over x, negative 128.842, divided by negative 62.929. And I got 63.968. And we want this to the nearest minute. So on your calculator, you would use your second angle DMS function. That ends up being 63 degrees, 58 minutes. So now, what does that angle represent? Again, this is the tricky part, getting the heading. That angle represents this angle right here, the angle from the x. That angle is 63 degrees and 58 minutes. So there's a couple ways you can express your heading. If you want to use that angle, I could say, well, hey, that's going to be west, 63 degrees, 58 minutes, south. That's probably the easiest thing to do, and that's probably how I would do it. But there's another option. If you want to list your south first, you'd have to get this angle there, which is simply going to be 90 minus this. So the other one you could have is you could have south, and then we'll get the angle in a second, west. And the angle that's going to go in there would be your 90 degrees minus 63 degrees, 58 minutes. And that would be 26 degrees, 2 minutes. So both of those are acceptable. I would probably recommend going with this one. I think that one's a little bit easier to do. You don't have to worry about getting that complement. Okay, last part. What heading to the nearest minute should the boat take to arrive at port, compensating for the current? So the boat needs to go on this path right here, but the problem is the current is pushing it that way, so it's actually going to travel on this path. Well, what I need to do is I need to steer the boat more this direction here so that when the current pushes on it, it actually follows this. So here's where we use the negative or a compensation vector. All right, so what I need to do is I'm going to figure out a vector this way, which happens to be negative c, so that now if I can point the boat in this direction, which we'll call this resultant 2, now what's going to happen is I'm going to point the boat this direction. The current is still really pushing it here, but the boat's actually going to go on this path. So it's really kind of simple. What I need to get here is I need my negative current vector. All right, so if I'm just going to take my original current vector from the previous part and negate it, that's going to be negative 1.389, positive 7.878. I'm still going to want the boat vector. Okay, so again, from part A, that's negative 64.318 and negative 120.964. So now what I want to do to get this R2, resultant 2, is basically I'm going to take my boat vector plus the negative current vector. Okay, if I do the math on that, I got negative 65.707 and negative 113.086. So now it just wants the heading. All right, so to get the heading here, I'm going to use my inverse tangent equation of y over x. So that's going to be negative 113.086 over negative 65.707. So what I got there is 59.842. Again, I'll do DMS because it wants it to the nearest minute. And I got 59 degrees. Sorry, it's a little sloppy. And 51 minutes. So again, here's the hard part. Getting the angle is great, but I want the heading. So that angle represents this angle here, the angle from the X. So if you notice, probably the easiest thing to do is to actually use that angle. I know I need to go west so many degrees south. So again, what I would probably do is just use that one and call it west, 59 degrees, 51 minutes, south, and be done. For those of you Navy purists, you'll want the angle off the south, so you're going to want this angle right here. So the other way, again, you could do this, not necessary, but you could. You call it south something west, and that angle that goes in here is going to be 90 minus 59 degrees, 51 minutes. That ends up being 30 degrees, 9 minutes. So both of these are acceptable. Again, I would probably recommend just sticking with that. Okay, so I hope this helps for concept 2. Actually, both illustrations are included here. If you have any questions, please reach out. I'm a simple email or Brave Square message away.